Okay, so in this section, what we're going to do is we're going to define the trig functions at any real number and at any angle. Before, in a previous video I uploaded, and probably in an earlier course, you saw how one defines the trig functions at an angle in a right triangle. In other words, at an angle that is positive and less than 90 degrees. Well, what we're going to do now is go beyond that. And we're going to have to use, as you can see here in the notes, we're going to use the unit circle. Now, what is the unit circle? Well, as it says right here, that's the circle in the Cartesian plane, the xy plane that is, whose center is the origin, and the radius of it is going to be 1. So the center is at the origin, the radius is 1. In particular, this point over here, on the x-axis and on the unit circle over here, this is point 1, 0. In fact, the unit circle is the graph of this equation, x squared plus y squared equals 1. Okay, good. Now, that's the unit circle. What we're going to do is this. For any real number, we can associate it to a unique point P that is on the unit circle. So for any real number, you give me a real number T, whatever that number is, I am going to show you how you can associate it with a unique point P on the unit circle. Okay? By definition, if T is 0, we're just going to have the point P to be 1, 0. Let me draw the circle again. Okay, so again, this is the unit circle. So P, 1, 0 down is right here. That's what you get if T is 0. That's just by definition. Okay? Now, what if T is positive? Well, then the idea is you're going to start at this point 1, 0. You're going to walk along the unit circle in a counterclockwise direction. And you're going to keep doing that until the arc you form is T units long. And that's really what I'm trying to say here in the notes. So again, you're starting here. You're going to walk counterclockwise until the arc you form is T units long. So if you want, until you are gone, until you travel the distance of T units along the unit circle. Okay, so you can imagine now that this little subarc is T units in length. The point you end up at, that is going to be your point P. See if I can, so P is P is the point that you end up at. Some point on the unit circle. Okay? So that's what we have here. Now, let me just say this. If T happens to be greater than 2 pi, okay, well, this is still going to work. What's going to happen, though, is this. You're going to travel the entire unit circle if T happens to be greater than 2 pi. So if you're going to start here, and if your T happens to be greater, you are going to walk around the unit circle at least 1 time. You're still going to end up at a point P. I mean, what is that point? Of course, that depends on what T is. That is going to depend on what T is. But you're going to traverse the entire unit circle at least once. And that's because the circumference is 2 pi. Remember, the circumference of a circle of radius r is 2 pi r. So for the unit circle, it's 2 pi. If T happens to equal 2 pi, well, then you're going to end up at 1, 0, the point where you started at, basically. Okay? Now, if T is negative, the only difference here is that you're going to walk clockwise. So let me draw this circle again. Okay? So again, we have the unit circle. So if T happens to be negative, you start at the same point. The only difference now is that you're going to travel clockwise like this. And again, you're going to stop once you have traveled the distance of the absolute value of t units. Remember, t here is negative. So saying it's t units long, wouldn't make sense. You're still going to end up at some point p, and that point is going to be associated with that t. Okay? So each t gives you a unique point p. I mean, as you can see, let me scroll back up here. As you can see here, if t is 2 pi, and if t is 0, or if t is 0, you're going to get the same point p. That's okay. But each t gives us only one point. That's really what's important. Okay, let me just scroll down here. Okay.